I think everybody can open this GitHub which I've gave last time, or you can just search and let me show you. GitHub. You can just open this particular repository. Okay, so take this. Uh, so you can bookmark this particular link actually. So daily we will be opening this particular repository, and then we will be practicing each and every topic which is mentioned in this particular report. So if you try to open this, you have to go to Docker engine. Okay. So if you click on that, so the first topic is nothing but Docker fundamentals. Okay. So you can go there, and so here we have Docker setup, a file. If you go there, so clearly I have documented like how to install Docker on your Ubuntu 20.04 LTS server machine. Okay. So these steps we have seen in two ways. One is you have seen manually how to install this particular Docker, and then we have seen how to automate this particular process using Vagrant. So this Vagrant file also is available here. You already know the steps how to follow it and how to install it. Okay. So both the things are available. It's up to you like which method you follow and install the Docker setup. And the next thing after that we have to know is nothing but let us try to understand the Docker components. Okay, let us try to recall what are the Docker components. And before that, so let us try to recall why we are going into the Docker containers technology. As we already discussed, Docker containers are the components which, let's say, if you try to understand this, let me try to explain through diagram. Let's say if you take normal virtual machine or a bare metal server, you will try to run some applications. Let's say you are running on this, you are trying to run some web application from MySQL, some Memcache server. So these are the applications which you are trying to run on your virtual machine or a bare metal server. Okay, so let's say it is a virtual bare metal server or some virtual machine. Okay, platform can be anything. Okay, virtual machine can also be called as like instance. Okay, cloud instances. Okay, so now after creating that, you have installed some operating system. Okay, so operating system, right? You have installed an operating system, and then you are running your application, right? Okay, so now these applications can be like, let's say, web application, web app, like Nginx or Apache. It's up to you. Okay, so it can be an Nginx or it can be Apache to web server. And let's say a database, like let's say MySQL, a PostgreSQL, whatever you want. And then we have cache servers, like Memcache servers like that. Okay, can be anything. Now, if you understand the core, how these particular applications are running, when you run some application, that application will be running in the background with some process ID, right? So there will be a process ID which will be created for this particular application which is running in the background. Okay, so this particular like service I will be handling through systemctl command, where I can check my services and all. How you verify your Docker, right? For example, systemctl status Docker. So this is how I verify my Docker service is running or not. So if you look this particular output closely, you can see there is a main process ID called 738. If you want the proof, you can just verify through the command called ps aux, okay, pipe grep docker d. You can say docker d is a command which is running in the background, right? So that's the reason I give this particular filter command called docker d, which I want to filter from the output. So now you can see this is the actual process which is running in the background. You can see the proof, it is 738. Is that matching? with the main process ID. So this is how it is. Okay. So in this way, we can identify that this is the process ID which is running in the background. Okay. And then 738, you can see there is a Docker D which is running in the background. Okay. So Docker D, and there is 7 processes which is running. And if you try to give this, you can see here system D is like trying to control this Docker D, and the Docker D is running here. Okay. So this is how it is. So this is handled by your system D service. Okay. So this is how we verify. These are the few commands to track what is a process and what is a service running in the background. Obviously, we use systemctl command, and from there we will come to know the main process ID, and then you can execute the psaux command and see what kind of process it is. Okay. So this is how it is. Now, so in this way, for every application which is running in the background, we'll create a process ID, right? So all these processes are running in a single namespace, which is called as root namespace in Kubernetes, in a Linux operating system. Root namespace. Root namespace in the sense, if you want to take some real-time example, let's say you are staying some home, right? Your entire home which you are staying, forget about the partitions. Okay, the main hall, the children's bedroom or main master bedroom or the kitchen which you have. Forget about all this. It is like your entire portion which you are staying is called as a root namespace. That's how it is. Okay. So all the processes are running. So let's say this is one process, this is another process, and this is another process. All these processes are running in the same root namespace. Okay. Now what Docker containers will do is nothing but your every process, like where every application which you are trying to run, you are trying to run as a container. So container in the sense, what Kubernetes or Docker will try to do in the background, it will create this particular application in a separate namespace, not in the root namespace. Okay, under the root namespace it will create another namespace. Okay, and then for this application, for this container it will have another namespace, for this container it will have another namespace, and this container will have another namespace. Okay, that's the only thing what Docker is trying to do. Because of this, what is the advantage? It doesn't have any operating system. It will have only the process, it will run only the process what that application needs. That's it. Okay, it is not running any other process. And these particular containers which are running are sharing the same operating system kernel. Okay, so your containers doesn't have any kernel to talk to the hardware. Okay, that is the first thing we have to remember. If you take your bare metal server operating system or a virtual server operating system, they will try to they will install the operating system. Without operating system, you cannot run an application. So then that operating system will have kernel and all the libraries and binaries which are required for that particular operating system to run or an application to run. Okay. But whereas this container will have only the libraries and binaries which are required to run that application inside the container. Then if it needs to talk to the hardware, what it will do, it will pass information to the base operating system where your Docker has been installed. Say I installed on Ubuntu. So it will talk to the Ubuntu kernel, which is like my kernel version is this actually. My kernel is 5.4 version. Okay, it will talk to this particular kernel, and that's how it will talk to the hardware for the CPU or memory or storage, whatever it is. Okay. So this is how it is. So root namespace by default will be there in every operating system. Okay. Now the containers, what it will do, for every container, it will create a separate namespace, and every namespace is individual right now, which means that this is another namespace for this container. So it is isolated. Okay. And this container is also running on a different namespace. Okay. So which means that now this container cannot see the information which is related to this particular container, and this container cannot see the information related to this or this. It is not possible because all these containers are isolated with each other. Okay, and a process or a thing which is running in that specific namespace cannot see the details of another namespace. That is not possible. Okay, as a root namespace user, I can see each and every namespace. That is obviously, right? Root can see everything. But every application cannot see the information related to the root namespace or any other individual namespace. Okay, so this is a in-depth topic. Actually, we have so many namespaces which Docker will try to create, and then it will use that advantage to run your containers. Actually, there are so many namespaces. We have a network namespace, a process namespace, memory namespace. Okay, we have so many other namespaces which will be created. This is one of the example related to process. Okay, so in this way, for every container, it will create some bunch of namespaces. Okay, and then it will be ready for your container to pass information through that particular namespace. Okay, that's how it is. So this is a small introduction related to how your containers are created and how they will be running in this technology. So this is the why the containers are more preferred than running your application as a virtual machines or something. There are some applications which you have to run through if it is a memory constraint or if you want a specific kernel. Okay, and then in those cases you have to go for your virtual machines to run your application. Okay, but you're not bothered about what kind of let's say you have some minimal kernel version, that's it. Okay, you're really not bothered about a specific kernel version, then you can run your application as a container. Okay, why? Because the reason behind this, all these containers are running on the same operating system and they're trying to use the same kernel. So it is shared, right? So this kernel, if you try to upgrade, it will affect all the containers. Okay, it's like that. Okay, that is one thing you have to remember. So now, yeah, so this is how, these are the basic introduction of how these containers are created, right? So in the components you will be talking about Docker server, which is nothing but, the Docker server is nothing but the daemon which is running in the background is called as your Docker server. Okay, now this is my Docker server. Why? Because my daemon is running here. Okay, now Docker CLI is nothing but, we have installed the CLI package as well. If you want to see that particular thing, dpkg-l grep docker-c, this is your CLI package. You can see this. Okay, and this is your server package which is installed. Okay, so these are the two different packages which you have installed. Okay, Docker registry is something where uh, let's say, as I told you, if you want to create a containers, we need to download the images. Okay, for let's say Ubuntu image, if you want to create a container related to Ubuntu, we need to download Ubuntu image. If you want to run nginx application, we already have some images which are present, official images, where you can download and you can create a container. Okay, so for everything you can download from the registry. So registry is something, a location where you can store the images. Okay, not only images, actually anything. Okay, so what is our registry then? What is the registry that we will be using by default when you execute a Docker command to pull the images is nothing but, if you want to see that, Docker info command. If you try to execute this command, you can see this particular registry. Okay, so this is the default registry where your Docker will be using in order to download the images. This is nothing but Docker hub. So this is where you will be trying to download. If you search for Ubuntu, let me search for that, you can see this is a tag. You can see here official image, which means that this is the official image which is provided by the community itself. Okay, Docker community, sorry, Ubuntu community itself. Okay, so official image, you can see how many downloads we have and how many star marks we have for this, star rating for this. So 10 million plus downloads it is. Okay, and you can see it is support for all the architectures like containers, Linux architecture. We can see the base image, it is operating system, that's it. Okay, if you click on that, you can see how to download. Okay, if you want to download this particular image to your system, then we use this particular command to download. Okay, so this is a registry. If you want, you can create your account. You can just go to the sign up and then you can create your own account. Okay, I have my own account where I stored my images actually. Okay, let me show you that. This is my Docker Hub account. You can see, if you try to see my Docker Hub, you can see my images which are there here. Nginx task, Ubuntu, Stress, okay, Jenkins master, utils, and Ansible server. So these are the types of what do you say containers which have images which have created and they pushed into my repository. Okay, if you want to create a repository, you can just create. The only thing when you have a free account is nothing but you can create only one private image, private repository. Okay, you cannot create multiple private repositories. For that, you have to upgrade. You have to purchase the license key. Okay, so it will be secured, and all the images, if you want to mark it as private, you can do it. Which means that when someone wants to download the image, they need to authenticate. They need to give my account username and password. Okay, so without giving that, they cannot download this particular image. Okay, it is not possible. If you want the proof, let me show you. If you take this particular image, right, in order to download this image, this is the command. Okay, so docker, it is not push, actually pull. Okay, so you have to give the name of my repository slash the image name Ubuntu, and what is the tag? You can see we have different tags: 16.04, latest, 20.04. Okay, so let me give 20.04. If you try to download, it has to throw me an error. You can see access denied. Okay, repository does not exist. There could be two reasons. One is repository may not exist, which I'm looking for. Okay, or it may be the Docker login is needed to download this particular repository. So second option is an actual issue for us. Okay, it's not that image is not available. Its image is available, but we don't have a permission to download it. Okay, so this is one thing you have to see always. So that is registry. So containerd, I will be talking about that later.
Sudhir,
Why?
Sudhir,
Because
I have a question.
yeah,
May I ask? Okay, so I have a
yeah,
question regarding the root namespace. So you said that
hmm.
the container will created into root namespace by default. Is that
Hmm.
mean that
Not
root
container, not container.
privileges?
See, not container. Whenever you
Hmm.
install a Linux operating system, any Linux operating system, by
Hmm.
default it will have a root namespace. Okay.
Okay,
Your
and
containers, whenever you create, whether through
hmm.
Docker or any other containerization tool you take, it will create a separate namespace under the root namespace of your Docker. Okay. By using
Okay,
Docker or any other tool, it will create a separate namespace, and that namespace will be under your root. Okay.
okay. So is that some security issue if I don't want to create? Means if I don't allow any container within the root namespace, means not root privileges. I'm little bit
Ah,
confused.
okay.
Uh,
So root privileges, in the sense, temporarily you are giving some root access to your
hmm,
container, to the root, what do you say, user, as a root user. That is a different
hmm,
scenario, privilege. Let's say
hmm,
I don't want a separate namespace for, let's say we have different namespaces, which I told you before, right? Network namespace and all. Let's say
hmm,
I'm trying to create a container. In for that container, I don't want to create a separate namespace for that networking. I want to use the host network. Means whatever the network was host system is using, I want to use the same network to my container. I don't want to create a separate network namespace. Then we can do that. Okay, if I don't want a process id namespace separate to be created for my container, so individually you can handle the namespaces altogether. You cannot create a container in the root namespace, but few components can be created in a root namespace, can be shared to your container. Okay.
Actually, I was reading Podman means comparing Docker with Podman. So Podman, I read that Podman don't allow to create a container in root privileges. It's create by
See,
default.
yeah, that is
So
something where we have
hmm,
some privileges. So root privileges, in the sense, a root user who is running inside the container and inside the operating system is different. Okay. So when you try to
hmm,
create a container, you will have a root user. Okay. That user and the root user who is running in the operating system is different. So that is one case. Okay. Now that is fine. Okay. So well and good. Now you can give the root access. Okay. Privilege, in the sense, what? The user who is running inside the container, the root user, can get access what the root user is running inside the operating system. Okay, what operating system root user can do, your container can also do the same thing. That is called as privilege, which you are trying to give. That is a issue, actually. We should not run like that. There could be some cases where you have to run that. Why? Because sometimes you might have to do some fine tuning to your kernel parameters. Okay, if you want to do change some kernel parameters from the container user itself, you have to do like that. But 90% of the cases we should not do like that. That is called as privilege escalation. Okay, so that is what he is talking about. So Podman doesn't allow you to directly do that. Okay.
So is that mean that Podman is more secure than Docker containers?
Yeah, containers. See,
In
Podman is also creating a container. In backend, they might
mm,
be using a different scenario. Okay, but
mm.
here we are using Docker. That's it. See, ultimately they might use some Podman PS command or LS command or something like that. We will be using Docker LS command, Docker image LS command, something like that. That's it. Container is a container. That's it. It doesn't change.
No, no. Yeah, you are right. But my question is, if I want to create containers, means
Mhm.
is my scenario, then
Okay.
if I will compare Podman with Docker, then Podman is more secure than Docker in terms of root privileges, because
You
by default
have
it
to
don't
see
don't
by
allow.
default. See, it depends upon which kind of image you are using. Okay, so there are so
Mm,
many criterias actually. Podman by default maybe it is not allowing you, but still we can do that. Okay, whereas if you take Docker, by default it may allow, but you have to restrict it. We have so many options when creating a container, right? So we have to give a proper privileges, and then you have to give a secured access to your container. So that we will be seeing when you come across namespaces and security. Then you will come to know how to
okay,
find your containers to run as a secured. They should not get a root privileges, right? So this is called as
mm,
security, which comes under.
okay.
Okay. So when we come across
Thank you.
that, then you will
Just one.
understand it.
Okay, just one small question regarding
Hmm.
registry. So, can we
Yes.
create our own registry or registry
Yeah,
server?
that's what, right?
So
See,
that
you can say this is my own registry. And one more thing, if you don't want this registry, you can create your own registry in your as a Docker container. Means one of the container will be acting as a registry, and you can share it to your team. Means like you can, but the only thing is you have to expose your Docker from running as a socket. You know, running your service as a socket.
yeah, I know.
Yeah, if you try to expose it to TCP protocol, then only you can store the images. Okay,
Okay,
if it is internally within the Docker host machine itself, you can store by using a Docker socket, you can communicate. But if you want to store it through the protocol, you have to expose your Docker daemon as a protocol. That as a task, actually, we have so many things like this. When you come across, you will come to know how to create our own registry as a container, and you can store the images. Okay, but we don't use it in this scenario in a production section. We use either JFrog, or we use if you are using AWS, we use ECR, Elastic Container Registry. If you are using Azure, we are using Azure Container Registry. If you are using GitLab, we are using GitLab Container Registry. So for everything, we have a registry supported by clouds and some open source tools as well. Okay, they are more secure than running your registries in storing the images in your own registry inside the containers. Okay, why? Because if your
okay,
Docker host machine is crashed, your container is also crashed, right? You cannot access it. What happened to your images which you have stored? You cannot access.
mm,
That's a problem actually. Okay.
okay. Thank you very much.
So now this registry is something where which is Docker is provided. I created my own account, free account actually. Okay. If you want to purchase a license key where you will get a secured image, you can scan these images automatically. Okay. So these things will be provided additionally when you purchase a license key. Okay. So I'm not bothered about that right now. So that's it. Okay. Later on, we will see how to automate the process, which means that if the image is pushed to the GitHub, automatically this Docker Hub account has to pull my images related content, and it has to build the image, and it has to store the image here. That is one of the automated process. Okay, we will see that in the coming classes. Okay, so Docker object is, see, these are the technical terms which I'm talking about. So container D, in the sense, your Docker is not itself is creating a container. Okay, so Docker is relying on container D service to create a containers. Okay, if you want to see that, let me show you that in this way. Okay, if you want to see that, simple, just execute this command. you will see this particular container D socket. Okay, it is not running as a process, it is running as a socket. You can see this particular, sorry. Okay, so this is a socket which will be accepting the request, and then it will create a containers for us. So Docker CLI will send the information to the Docker daemon, and the Docker daemons will send the information to this particular container D to create a containers. Okay, that's one thing you have to always remember. Okay, so Docker itself is not creating a containers. Docker is relying on container D service to create a containers. Okay, that's one thing you have to remember. So that we will talk about more in the coming classes, and that's one thing you have to remember. Docker objects is nothing but images, containers, volumes, networking, what we talk, right? Those are called as Docker objects. Okay. So these are the components which we have in the Docker. So that is what we have discussed about that. So if you want to see the Docker server related information, though, that is what I have shown here. You can see a sample output of this. Okay, how to verify. So Docker daemon as a service is a service that is running in the background to handle the request from CLI or the API calls which you run to create an object for application deployment. So what are the applications you want to create, or the what are the objects you want to create, like volume, network, images, containers, and all. Your CLI will pass the information to the Docker daemon. So Docker daemon is nothing but this, a service which is running in the background is called as daemon. Okay. So in Linux operating system, when someone talks about daemon, means a technical term called daemon, which is nothing but a service which is running in the background is called as daemon. Okay, so just remember that point. Now this is how it is. Docker CLI is nothing but whatever the command I execute, right? Docker, let's say image ls command, okay, or let's say Docker info or Docker version. So these are the CLI commands which are run. Okay, so this CLI command will pass information to the daemon to get the info. Okay, so Docker registry I have already shown you what is the Docker default registry. We have so many registries to pull the image and to store the images, actually public and private both. It's up to you whether to tag the image as public. Public in the sense what? No need to authenticate, directly you can download it. Okay, whereas private images in the sense it is secured, you have to authenticate and then you have to download. Okay, so here I given you some examples related to other registries which we have. Okay, and the default registries we have already explained. You can open this particular link and just you can read this particular document about registries. Okay, so container D runtime, which I've already told you, container D is used for Docker as a backend component to create and run applications. Container D is available as a daemon for Linux and Windows. It manages the complete container lifecycle of its host system for image transfer, storage of the containers, execution, and supervision of low-level storage of networking attachment. So there are so many things which container D can do. So this is the actual component who is trying to create a containers for our Docker. Okay. So what Docker is doing, Docker is collaborating all these backend functionalities or tools, and then it is available for us. So that's the reason it is so flexible and easy to use, this Docker component. Okay, and Docker component is cross platform, which means that you can install anywhere. Docker can be installed on MacBook, Windows, Linux, Unix, everywhere. Okay, so that's how it is. And images, you already know that. This is few points which I want to talk about this, but before that I have to show how to download the images and how to create a containers, and then we will come across this particular topic. Okay, so what is the image, how it looks and all. So after this topic was done, then you have to go to the Docker daemon. Okay, so how to verify it, I've already shown this. Okay, so let me cross check once again. So if you want to see every service which is running in the background, let's say your Docker service is running in the background, which means that it will run a command in the background. What is that command? This is the command. So this is the actual command which is trying to run your service in the background. So if you want to start your Docker server, this is the actual command which you have to start. Okay, remember this point carefully. Service in the sense what? Through systemctl command, it is handling this particular process automatically. Why? Because which command should run in the background, how it should restart your service and all, it is already written in this configuration file. Okay, so if you see that, okay, so you can see it is already written what command should run in the background. Okay, if you want to start your Docker service, you have to run that particular command in the background. Okay, simple. You can execute this command and you can throw it in the background. Okay, instead of you doing that, systemctl is handling it. Okay, that's one thing you have to remember. Okay, systemctl is automatically handling it. For this particular command running in the background, it will create a process ID. Okay, so that is how it is. So if you want to know whether this particular command is really available, see, command is in the sense it's a binary. Okay, so if you want to see what is the path of this, you can execute a simple command in Linux called which docker d. If you don't know the complete path of this command, you can see this user bin contain docker d. Okay, so this is the maximum things that you have to verify. Okay, and these are the configuration file. Always remember your docker configuration file is this configuration file, in the sense service configuration. Okay, so docker server service configuration file is this. Okay, so this is how it is. Okay, and this is the command which will be running in the background in order to start your docker server. Okay, so this is the command. If you want to know about this, either you can execute a psaux command and you can give docker d. So this is what it is, the command you can see here. Okay, simple. I will show you this. If I execute sleep command is something, it will execute this command. If you execute this command, it will not allow you to run anything. The terminal will sleep for the seconds what you specified. Let's say 1000 seconds. Now, if I run any command, it is not accepted until that particular command is completed. This is what you mean to say running the command in the foreground. If you run your command in the foreground, you cannot execute anything until that particular, either the command should be stopped, that means the process should be stopped, or you have to complete this until you have to wait until this command is completed. Okay, if I give control C, now this process has been stopped forcefully. Okay, now if you don't want this headache, I want to run this particular command in the background. What we will do, we will give dollar like and symbol. Okay, if you give and symbol, what will happen? It will run this particular command in the background. You can see there is a process ID created and it is thrown in the background. Okay, if you want to see that, ux command grep 1350 is a process ID. You can see this command is running in the background. So that is what your docker is doing. So instead of running this command like this, okay, so it is running through, it is executing this command through systemctl command. Okay, so that's a minute points which you have to remember. So this might help you for troubleshooting. Okay, so any questions with this? If you want to run command, that command where until this command is successful, see this command is a immediate executable, right? It will execute within fraction of seconds, but there will be some commands until those job is done you have to wait. Okay, you will never notice like this until you execute these kind of commands, right? You'll come to know about this particular functionality. So now I gave it an end symbol at the last, which means that run this command and throw it in the background. Okay, so that is what we have done right now. Okay, so I hope this makes some sense, understanding this particular process and how it runs in the background and all. Okay,
Uh,
so
is it
FC.
possible to
Sorry.
I'm saying that is it possible to access this Docker server remotely? Means I might means to say that.
Yes, yes, we can. Yes, we can.
Okay.
Okay. By default, now what? Yeah, the question which you asked is nothing but he's asking something like, he's saying that Docker server is running on one machine. For example, let's say he installed Docker server on this machine. Okay. Now he's saying that if I install Docker, if I want to communicate from here, is that possible or not? This is another machine. Let's say this is a client machine. Okay. From here, if he wants to communicate to this particular Docker server, is it possible or not? Yes, it is possible. First thing what you have to do is nothing but you have to install Docker ce-cli package. That is the first thing you have to do. Once it is done, in the Docker server, by default your Docker server is listening on Unix socket. You have to convert that into, so now you have to ensure that your Docker server is listening on TCP protocol. So that is what you have to do. Okay, so hope you understood. Then you can execute the command. Then you can execute the CLI command from here and it will talk to this particular Docker server. Okay, yes, that is possible. Okay,
Will we do this small exercise in coming classes?
yes, of course, why not? It's a part of the course. These are mine. These are the things, right, which we have to discuss.
Okay.
So, like you can restrict
So,
your questions. See, try to restrict your questions to the topic which we are discussing, so that others will not get confused. Because I have to spend some time to explain this, right? They may not understand about this. Okay, so let us restrict our questions only to the topics which we have discussed right now. Okay. Yeah, any questions?
Sudeep, yeah. So if we install the Docker in the Windows, do you
It is
need
running as
the
a
root
desktop.
privileges to? Yeah, Docker desktop. So do we
Yeah.
need the root privileges? Admin access is required to run the commands.
No, no, no. It's not required. No, it is not required.
Okay.
So by default, what it will do, your username will be added to your group called Docker group. Okay, automatically it will be added. So that's the reason where you can run your containers as a desktop from your user. No need to start that particular Docker desktop from the administrator. Okay.
Okay. Okay.
Yeah. So this is done. So now let's try to understand. So open the document and try to understand how to execute the commands. All I explained here. Okay. So you can just execute these commands. Okay. How to, what is the
Sudhir,
configuration file?
will
Sorry.
there be only one? Uh, will there be only one Docker host running on one host machine, or can
Yes,
we down?
you cannot.
There is
See,
only
you
one
cannot
Docker
run.
D.
See, we cannot run multiple Docker D commands. See, Docker, you are saying like on single host machine, you want to run multiple Docker servers. So that is not right. So we can do some fine tuning, but the problem is the socket which is already used by one of the Docker server cannot be used by another container, so another Docker server, right? So that's the reason it will get conflict. Okay. So you have to do some fine tuning. So you have to create another socket with some name, and then you need to start your command using that and all. You have to do so many things. Okay. So there are some particular things. See, when you execute your Docker CLI command, right, by default it will go to the Docker daemon, which is listing on a default socket. But now when you execute some Docker CLI command to talk to that specific Docker daemon, you have to do some you have to pass some options. So never ever, no one will run, whether it is a testing or production or whatever it is, never everybody will run this. No one, actually 0%, no one will run a Docker daemon multiple times on a same host machine. Okay, it's not a right solution or right way to run that. Okay.
Okay.
Yeah, because it needs so many fine tunings actually. So instead of maintaining that headache, they will try to run on a separate missions. Okay. Yeah, so coming to the next document. So after this, you have to go to the default parameters and you have to understand few things. Okay, so there are few things which you have to understand when you install Docker. What are the default things that will be created by your Docker? Okay, till now we haven't seen, right? What are the default parameters or things which will be created by your Docker or Docker host? Some people will call it as Docker host or Docker host machine or Docker server. So both the things are same. Okay, if you install Docker server on the host machine, it is called as Docker host. Okay, Docker server in the sense it's a direct statement it is. Okay, so don't get confused with that. Now here I want to see what are the Docker related information where it will get stored whenever I download some image or whenever I create a container, whenever I create some network, whenever I create some particular volume, all these things where it will get stored. Okay, so that is called as Docker root directory. So Docker root directory in the sense the location where a Docker related information will get stored. Okay, so that if you want to identify Docker info command, if you execute this command, this will show you Docker root directory. So which means that all the Docker related information by default will be stored in this particular location. We can just change it actually, but by default it will store in this location. If you try to install Docker on any Linux operating system, you can see the same location. Okay, so where lib Docker. You can see images are stored in this image directory, containers are stored in this container directory, networks are stored in this network directory, volumes are stored under this volumes directory. And there are some other directories, plugins, storage drivers, okay, build kit. So this is for building the images and all. So there are specific directories which will store specific related information to that particular directory. Okay, so containers related information will be present only under this particular directory. That's how your Docker tool is designed. Okay, so that's how it is. Yeah, if you want to change this particular default directory, yes, we can do it. That will be a part of the sessions. Okay, so now no need to worry about how to change this particular directory location. Okay, so that is the first thing which I talked about. Okay, you can just look at this particular document and you can understand that. I gave you a sample output as well to understand whether you have executed the right command or not, with the right output or not. Okay. Next thing, how to check Docker information like total images, number of containers running, stopped, etc. and all. If I want to see how many containers are created, in that how many containers are running, how many containers are stopped and all, the same command, Docker info command itself. So if you go to the top, here you can understand that. Okay, in the server you can see how many containers are created, in that containers how many are running, how many are paused and how many are stopped. There are 0 images right now, there are no images at all. If you want to see what is a Docker package you have installed right now, 20.10.7, what is a storage driver you are using, what is a logging direct driver, C driver, plugins. Okay, so there are so many things which will be provided in the Docker info itself. Okay, so that's one thing you have to remember this command regularly if you want to see the default parameters. And if you want to know what is the default networks that are available when you have installed Docker. See, after installing Docker, I did nothing. Okay, this is the mission which we have installed Docker manually, right? If you remember, in the starting course I have shown you how to install operating system, and after that I have shown how to install Docker on this is the mission it is. Okay, after that I did nothing. Okay, so if you execute Docker network ls command, okay, you can see these are the default networks which are available in your Docker. If you try to delete this, see what will happen. Docker network remove. Okay, let's say bridge. Name of the network is, first one is bridge. If you try to see, cannot be removed. Bridge is a predefined network. It's a predefined network which is created by Docker Daemon itself. So you cannot remove it. Okay, so this is restricted. So these are the default networks which are created by your Docker itself. So bridge, we have host, and then we have none. So these are three different types of networks which will be created by Docker, and let us discuss about this in depth when we come across networking part. Okay, but I just want to show you these are the three different networks which are created by Docker itself, and if you try to delete, it is not allowed. Okay, that's one thing you have to remember. So when you try to create a container, so that is how it is. And one more point is nothing but below command shows that Docker 0 was a default bridge network used by containers launched on Docker host. So let's say when I try to create a container, let's say when I try to create a container, what is the default network that is used by your Docker? The default network used by Docker is nothing but bridge. Okay, so this is the one which is used when you try to create a container without passing any parameters. Okay, without passing any parameters, when you try to create a container, that container will try to get a network from this particular bridge. Okay, so that if you want to see the what is a network CID for that, you can see this. Last time I told you, right? I will just discuss about this particular third interface which you see on your Docker host machine. That is nothing but Docker 0. This Docker 0 is nothing but information related to this particular bridge. Okay. If you want the proof, you can give Docker network inspect and then bridge. If you try to execute this command, if you scroll up, you can see this. You can see the name, bridge it is. Okay. And you can see the network CID here. Is that the same? 172.17.0.0/16. Okay. If you want the proof, let me show you. That you remembered, right? What is your Docker bridge name? Docker 0. Okay. So if you execute the command also, it's the same. Is it the same CID here? So can someone tell me how many containers can be created in this network? By using that network, how many containers I can create? And how many networks I can create? Containers in the sense like how many IP addresses we can assign to the container, right? So that's the reason I told that actually.
Yeah, 254 into 254, I think.
So obviously, so 255 into 255. Okay. So total somewhere around 65,536 or somewhere. Okay. Plus or minus like that. Okay.
Yeah.
So 65,000, which is more than enough. Right. Obviously, more than enough for me. So how many networks you can create? Okay. You told like how many IP addresses. How many networks? How many networks? You have the formula. Right. What is the class of this CIDR? Which class it is?
Yeah, it's class B, but yeah, we have 16 bits, so we can use all bits for networks.
Only? How many? Sorry, come again. Your voice is breaking actually.
Okay, I'm saying that we have 16 bits extra, so we can use
No.
those.
Let's come in this way. Which class it is?
It's B class.
What is the B class default subnet mask?
255, 255.
Means what? /16?
Yeah, /16.
What is your subnet mask? /16 here, right? You can see there.
Yeah.
So did you borrow anything?
No.
No, right. So 0 means only one network. 2 to the power of 0 is equal to 1. Only one network. Okay.
Yeah.
Only one network. In that network, 65,535 IP addresses can be used. Okay. Simple. That's the reason it is really important for us the default subnet mask of each and every class. Class A, B, and C. Class A is /8, class B is /16, and class C is /24. If you want this proof, you can use this calculator, network calculator, right? So
So
calculator
what
like
will
this.
we assign this IP address to?
Sorry.
And what will we assign these IP addresses? Is it applications, content, or containers?
Containers. See, that's what I'm saying. Your containers will get an IP address, right? Nothing but your applications which are running inside it. Okay, let's say now you assign some VM, your VM is having some IP address from the bridge. Okay, so if you run an application inside that particular VM, with that IP address I can access it, right? That's how it is.
So you
You
can
understood the
host the
statement?
65. Yeah. So you can host 65,000 plus containers in this
535
Docker.
containers in this network using that network. Okay, you got it?
Yes. Yes.
17.0.0. Okay, so now if you try to calculate, see, did I told the same thing? 65,536. If you do -2, those are the number of usable hosts. Okay, so it will start from here. The IP address range will start from here and it will end it here. Okay, so if you want to see that, I think this table is huge, so that's the reason they will not show you. Okay, it is too huge actually. Okay, So that's the reason they don't display here. Sometimes they display, but here I know it is not displayed. Yeah. Okay. You can always confirm with this. So it is C. You can see it is telling you IP class is B, and the CIDR notation is /16 for this, and it is a private network. Okay. Yeah. So with this we have, so this is the default CIDR which will be created, and that's how it is created. Okay. So which means that as per the diagram, so let me try to clean up this and let me show you how it looks. So which means that now there is a bridge created. So this is a software bridge. Okay. So this bridge is named as Docker 0. Okay. So you can go on mute so that I'm getting some background noise. 172.17.0.1/16. Okay. So this particular bridge or software bridge is nothing but this will be connected to your base operating system, like wherever you have installed, right, your Docker, that particular host machine will have some interface. Okay. For example, let's say I'm trying to explain this. Okay, watch carefully. So let's say enp0 s3. If you see this, if you go to your machine, see this is your base operating, like your virtual machine interface. Okay, so which means that one end of the Docker bridge will be connected to your network interface on that particular machine. So when you try to create a container, every container, okay, by default, if you don't specify anything, this containers will get attached to this particular bridge, and they will get an IP address from this particular bridge, which means that this container, let's say C1 container 1, and this is container 2 C2, and this is container 3 C3. Okay, now let's say 172.17.0.2/24 or 32, like that, 32 it is. Let's forget about that. Let's say only IP address 172.17.0.3. So in an ordered way, 172.17.0.4. Okay. Okay. So from by default, it will contact to your Docker 0 bridge interface, and that's how it gets an IP address. So from this container, I can communicate to the internet. Okay, and from this container, I can talk to this particular container which is sitting on the same network. Okay, from here, I can ping from my Docker host machine. If I try to ping Docker container, it will be possible. Okay, 172.17.0.1. This is a bridge. So bridge IP will be reachable. So bridge is nothing but, which means that when I execute this command, it is getting a response from this particular interface, bridge network. Okay, so this will be a gateway. 172.17.0.1 is a gateway for all the containers which are sitting on this network. Okay, if I want to communicate also, when I want to communicate to this container, first it will reach to this particular gateway, and then it will reach to that particular destination, because this interface knows, right, where is this particular container, this IP address is. Okay, then the packet will be sent to that particular container. Okay, so this is how it is. Okay, any questions on this, in understanding this, or is that clear, right? Okay, so after this you have to understand the storage driver. You can execute this command. So the default storage driver which we are using is overlay. So in the disk, right, if you remember, whether you are using Windows operating system, or when you are using pen drive, or when you are using Linux operating system, everything which it is trying to write into the disk or the storage, okay, device, right, it will use a file system. File system in the sense, it is a protocol which will be followed when you're trying to store some content into that particular device. Okay, hard disk or anything, floppy, or your pen drive, whatever it is, okay, USB stick, whatever it is, everything will have some file system, which means that it will follow some particular protocols in order to store the information into that particular device. Similarly, when your container is created, your container will have a layer. I will talk about that later, but it will have a layer. In order to store that particular information related to container in that layer, it will use this particular storage driver by default. By default, if you install Docker on any Linux operating system, whether it is a Ubuntu or CentOS or Red Hat or anything, by default you will get overlay 2. This is the latest and recommended one. Okay, default storage driver. Okay, so that is a benefit of it. So if you want to change the storage driver, yes, we can do it. So that is a part of the course. We will see how to change your default storage drivers. Okay, just one thing. So with this, we have completed the fundamentals, like what is needed, how to understand what are the default parameters, and how your Docker daemon is running, what are the default configuration file, service configuration file of your Docker, and this. Okay. So with this, we understood something, and from tomorrow we will be creating containers to deploy some particular applications on the container level. Okay. We will see how to pull the images, how to create a containers, and all. Okay, so try to use this particular repository. Always I will refer this and I will talk about this. Okay, this is already present in my visual code. If I open this also, it will be having the same. Okay, if you, for your comfortability also, you can install this Visual Studio. It is so comfortable for you to access and read and do some modifications as per your requirement. Okay, Visual Studio code. Okay. So that's all for today. So this is the basic introduction related to your Docker default parameters and settings. Okay. Any questions? Any
Hi,
questions?
Subhash.
Yeah.
Yeah, this basic question. See, whatever we are doing with Docker, right? I mean, we can do with virtual machines also, right? Why do we need Docker specifically?
Virtual machine. It's
Yeah,
a general thing which I explained already. Yeah, but install on operating system, right? Okay. To run
yeah,
that particular operating system, we need a lot of services that should be running in the background. Of course, my
yeah,
statement is true, right?
yeah,
Yeah. So to run that particular services, will that consume some CPU and memory and storage?
yeah.
So when you want to run some particular application inside that particular virtual machine, the resource what application wants to use is not full-fledgedly used, right? So few resources are already used by your operating system itself. The left of the resource will be utilized by your application. That's the first statement why we are going into the containerization level. In the container, you don't have any operating system. It will have only operating system related libraries and binaries, not the kernel. If you have a kernel, resource to consume, it will consume a lot of resources. But in the containers, we don't have any kernel. It will have only the libraries and binaries which are needed for that operating system to run the application. Okay, that is the first statement why we have moved into the containerization. Second point is nothing but for virtual machines, if you allocate some resource, let's say I allocated some CPU, some memory, is that possible to change whenever it is needed based on the requirement of application?
No,
No, right? So you have to shut down and you have to take some non-business hours, some change window or something, and you have to do some changes. But
yeah,
in containers, whenever it is needed, it will increase automatically. The resource, if until unless you specify some restriction, it will use dynamically and it will reduce and it will increase dynamically. So scale in and scale out of the resource will happen dynamically. That is the second point why we have moved into the containerization technology. So these are the two major factors why everybody is interested to move into the containerization level. And running an application inside the container takes less than fraction of seconds actually, but for a virtual machine it will take some time. You have to install the operating system and then you have to run your application. It needs a lot of things, right? So these are the three major factors why we have moved into the containerization. So did I answer your question or still is
yeah.
it
I'm
right?
good.
Okay.
Thanks.
So make these points. So when someone asks you an interview like why we have to go, so you can make this particular 3 points as a major points. Okay.
Sudhir, when you say scaling out, what
Yes.
resource? I mean, uh, from
Let's
where
say
will the Docker
today
get the
today my container is
spike?
today my container is using only 20 GB of RAM. Sorry, let's say 200 MB of RAM. Okay. So there are only less users, no clients at all. My application is running okay. Now the clients got increased, means the number of hits to my application has been increased. Because of that, what will happen? Application will try to consume some resource, more resource to handle that particular request, right? So when it wants to handle that particular request, so obviously it will consume some amount of CPU and some amount of memory to store the information, temporary data or whatever we say. So when you have only 200 MB, it is may not sufficient. Now it should increase based on the requirement. So that will happen in containers automatically. Okay,
No,
that's
no.
my
From
statement.
where will is it
See, that's what. See,
taken
it
from
will talk.
the host?
Yeah, that's what I told, right? So your container doesn't have any hardware, right? It should talk to the base operating system, and base operating system will increase the resource for that particular container. Okay. See, your
But here
container
in this
doesn't
case,
have any.
uh,
Yeah, go ahead. Go ahead. Sorry.
Windows machine. Here in this case, it will take from your host Windows machine.
Not Windows machine, virtual machine. I installed on virtual machine, right? For virtual machine, how much amount of CPU and memory I've allocated, it will use only that.
Okay.
That's how it is, right? See, if you have installed your Docker on Windows machine, then your statement is correct. What you're asking, okay? What you're thinking actually. See, where I installed Docker, that's the main thing. So that's where the people will get confused. You are still thinking that Docker is running on Windows. No, it's running inside the virtual machine. So what are the resource I allocated to virtual machine? That will be the resource to my Docker. Okay. I hope that answered your question or something.
Yeah. Right, right. But this in production, this will be very limited resources, right?
See, in production, we don't do like this. See, in productions, we run Docker on a bare metal server. It's not like this. Okay, that's what I want to clearly make a statement. Okay. In productions, it depends upon the requirement. Okay. Always, it doesn't mean that you have to run on a bare metal server. Okay. Sometimes it may need, if you run some large applications and you don't want to create a virtual machine and run some containers, you can directly install your Docker on a bare metal server and then you can create a containers, right? That's how it is. Okay.
Okay.
So we can make our, you can park your questions in the WhatsApp group, or else we can discuss when we join the session tomorrow. We can discuss from your questions itself. Okay, QA, and then we can start our topics. Okay. So sorry for stopping here because I have another class, so I need to uh, jump in there. Thank you. Any questions? Please post in the WhatsApp group. I can answer there and the rest of the questions. Okay. Thank you.